Hello everyone. In today's video, I'm going to do proving again. I'll do the course series tomorrow because I'm a bit tired today. So I'll do a short video for yeah for now. So prove that 1 over x continuous at any arbitrary point C using from epsilon delta definition. Okay. So for the epsilon delta definition for our continuity, is given that for every C in the interval I, and for epsilon greater than 0, there must exist a delta greater than 0 such that our distance x minus c is less than delta. That implies that our distance f of x minus f of c is less than epsilon. So we need to find um, a delta. We need to choose a delta so that f of the distance, this distance is less than epsilon whenever um, our x, the distance x minus c, is greater than 0 but less than delta. So to do that, first we need to have our function of x is 1 over x, right? So 1 over x minus f of c, which is 1 over c. Well, it must be less than our epsilon, right? So we have as cross multiply c minus x over xc is less than our epsilon. Well, we can make this into this form by the property of absolute values. Since c here we don't know the value, so we can split them, and notice that c minus x, when you take the absolute value, is always positive, so we can change it into x minus c. Why? Because, well, we can factor out negative. It will be absolute value of -1 times x minus c, right? For absolute value of xc is less than epsilon. Wait, let me just split this now. Xc is less than epsilon. Well, this will be positive 1, so our x minus c over absolute of x times absolute of c must be strictly less than our epsilon. Well, we need to find um, a delta boundary for that this 1 over absolute of x doesn't go to 0. Well, that makes it this undefined. So we need to have delta is less than equals to, if we choose 1, then when we c equals to 0.5, this will be undefined. So we need to choose c is over 2. Okay, so we can assume that our x minus c is less than our c over 2. Okay, so we assume this. um, Doing that, we have um, negative c absolute of c over 2 is less than our x minus c is less than our absolute of c over 2. Well, to have a cleaner bound, we need to use the triangle inequality. Well, we are given that absolute value of x is the same thing as what? Absolute value of c minus x plus c, right? Wait, don't do this. We have to add that. So add x minus c. Well, it will be the same thing as absolute value of x. So using the triangle inequality, we have is greater or equals to our absolute value of c plus absolute value of x minus c, which is greater than, well, absolute of x minus c. Uh, we know that it's strictly less than absolute value of c over 2. That must mean as is absolute of c plus absolute of c over 2. Okay, and this must be greater than absolute of c, right? Absolute of c, I mean, over 2. Okay, so our absolute c plus absolute of x minus c is greater than absolute of c plus 1 absolute of c over 2, then it must be strictly greater than absolute of c over 2. That means absolute of x must be greater than absolute of c over 2. Implies that if you take the reciprocal, we have 1 over absolute of x is the same thing as yeah, sorry, it's less than 2 over absolute value of c. Okay, now we have this, right? So we have x minus c, apply the boundary, also x times absolute of c, it must be less than, since we know that 1 over absolute of c is less than 2 over absolute of c, that means this must be strictly less than x minus c over 2 absolute of c over 2 times absolute of c. This is the same thing as absolute of x minus c over this one times 2 c squared. We know this is less than, strictly less than epsilon, so that implies that this is equivalent to x minus c, which is less than our epsilon times absolute of c squared over 2. Okay, now we have um, these boundaries. So we have delta to be the minimum values of our c and epsilon c squared over 2. So using the formal definition, we have let epsilon greater than 0 be given, or let or epsilon equals to 0. Given that epsilon is greater than 0, we choose our delta, and don't forget c is in the real numbers, delta to be minimum value of c sorry, I made a mistake, it's supposed to be 2 over c, 2 over absolute c, and we have epsilon c squared over 2. Okay, now if we have the distance is strictly less than delta but greater than 0, well, we know two facts. We know that first, since delta is less than equals to our absolute of c over 2, we have that what absolute of x must be greater than absolute of c over 2 plus absolute of c. That implies that we have absolute of x is less than 2 over absolute of c. And also, since we have delta be less than equals to absolute value, epsilon times absolute of c squared over 2, we have got our x minus c, so is strictly less than epsilon c squared over 2. Well, using this, we have applied into the boundaries. So our absolute of 1 over x minus 1 over c, that's equivalent to c minus x over absolute of xc. Remember, it's equivalent to x minus c over absolute of xc, which is the same thing as xc, x times absolute of our c. And we know that this equation here must be less than what? Our epsilon absolute of c squared over 2, and then, or 1 over absolute of c. Oh, sorry, this is 1 over absolute of c. Must be strictly less than 2 over absolute of c. That means this is times by, we change substitute the 1 over absolute value of c, we have 2 over absolute of c times by our 1 over 1 over c. And we have, this is equivalent to epsilon c squared over 2 times 2 over absolute of c squared. This cancel out, cancel, which is equivalent to our epsilon. So we have x minus c over x absolute absolute of c must be strictly less than our epsilon. Hence proven. So, okay, that's it for this video, and hope to see you on the next video. And thank you.